Hello everyone, I hope you're all well and looking forward to today's webinar. I'm Donal O'Malley of Kaizen PLM and I'm joined with Heinrich Flum of Janus Engineering. Today we're going to present to you NX CAM and Technology Manager from Janus Engineering. Today's webinar is Streamline CAM Programming and Machining Processes with NX CAM and Technology Manager. Just to give you a background on Kaizen PLM, we are an Irish-based Siemens Digital Industries Software Gold Partner. We provide solutions and support solutions for CAD, CAM, CAE analysis, virtual commissioning, Technomatics, MCD, additive manufacturing, Teamcenter, Polarian, Mendix and Keyshot. We are a specialist partner for the additive manufacturing portfolio from Siemens for the UK and Ireland. We also provide 3D scanning services, so we can provide a service of scanning components for you, or we can provide the hardware for such scanning. And to speak a bit about Janus Engineering, they're Siemens Digital Industries smart partner. They have offices across Europe and one in the USA. They look after solutions for CAD, CAM and PLM. They also provide various NX CAM plugins to enhance capability and streamline processes, all within the NX environment. As you can see on the slide here, the Siemens software portfolio offers a lot more than just CAD. Siemens are the largest engineering software company in the world and offer everything from manufacturing execution systems to electronic design and low-code app development platforms. As we can see on the top left for mechanical design, we have NX Solid Edge, FiberSim, SynchroFit, MasterTrim, Somatic IT, R&D. There's within NX, obviously we have the CAD CAM. We also have simulation analysis tools within that, and the same as with Solid Edge. Under the software portfolio, there's solutions for a vast array of applications for electronic design automation, software delivery, simulation and test, performance analytics, manufacturing operations, automation, manufacturing planning, and all these can be made work together in collaboration using Teamcenter and MindSphere. As can be seen in the slide here, NX CAM has the capability to program any job regardless of the machine. High-speed machining methods, 2.5 axis milling, 3 axis milling, 5 axis milling, turbo machinery milling, fixed plane and hybrid additive manufacturing, multifunction machining, 2 and 4 axis wire EDM, hole making, turning, robotic machining, extensive tool libraries, efficient shop floor documents, on-machine probing, post-processing, machine tool NC code simulation, and CMM inspection programming. This short demonstration will take us through the entire process, starting with the model preparation. Any standard CAD data can be read into NX. You can quickly create a fixture that is associative to the part by using the advanced CAD capabilities. Components from the parts library can be used to complete the fixture. To create the stock model, you can use synchronous technology, which enables you to directly edit any CAD model. You can close holes, offset faces, edit blends, remove slots, and remove drafts. The setup is now ready to be programmed. You can automate CMM programming by using the PMI data, such as tolerance and surface finishes, that is enabled in the model Validating the inspection path in the context of the CMM machine ensures safe inspection process on the shop floor. The inspection path can be easily adjusted. In this case, the number of measurement points on the top surface is changed. Immediately, you can visualize and simulate the updated inspection path. At the same time, using the same model and working in the same NX environment, you can create the NC programs to machine this part. Using the advanced 5-axis machining capabilities in NX CAM, you can generate toolpaths to efficiently machine complex parts with minimum number of setups. The second machining setup is used to machine the outer side of the part using the in-process workpiece technology, which dynamically tracks the removal material. The helical Z-level operation machines the inside walls with improved cutting conditions. Machine-specific CNC program can be output with the integrated processor system in NX. A complete shop documentation is essential to have efficient production on the shop floor. Design changes can be handled easily and reliably with the model-driven process. In this case, the new revision of the part features a different hole location and a thicker rib. The integrated NX system enables all of the geometry and programming information to update automatically. The fixture geometry is updated to accommodate the new geometry. The associative toolpaths regenerate to the design changes. Also, the CMM inspection paths get updated based on the new geometry. You can verify the new programs with the integrated simulation in NX. Here we can see the CMM going through its points. Machine shops produce parts for many different applications across different industries. These are some of the key manufacturing domains, and each of them have different requirements. Production machining typically involves production of larger volume of prismatic parts used in almost any industry. Complex parts made of lightweight materials such as those in aerospace and medical industries often require 5-axis machining to cut the complex designs on multi-axis machine tools. Industrial robots' estimated compound annual growth rate is the second best among all robotic domains. This emphasizes the trend to introduce more robots in various industries by replacing labor tasks and other processes like traditional milling and CNC machines. The 3D solid model can be read or designed in your CAD system. The digital twin of the part model is the input to the manufacturing process. Ideally, you want to work in the same software system where you design the 3D part model and define the entire setup including the fixture so that we have one consistent environment. By using the same model definition, you can take the data into the CAM module for NC programming to create and validate G-code to drive the machine tools. Create an associative and complete shop documentation using a digital twin of the complete machining setup lets you drive efficient and flexible production process. For example, if there is a design change or if you need to change a fixture, this update can be automatically replicated in the documentation all the way to the shop floor. In parallel, your quality team can work on defining the inspection process. Increasingly, companies are using product manufacturing information or PMI attached to the model. The PMI data can include the tolerance and surface finish information. Traditionally, this info would have been on drawings and you'd need to manually enter this data into your CAM or CMM system. Today, using the latest software, the PMI can be added to the model definition during designing the part and then use this data to automate your programming. In this case, you can automatically create inspection programs from the PMI data on the part model and then produce inspection programs that are sent to the coordinate measuring machine. Here you can see the use of consistent digital thread through the entire manufacturing process. With NX you can use one model in a single software system to go from part preparation right through programming and then down to production. This model-driven process is one of the key tenets of the digital machine shop that can give you a complete advantage over the competition. Associativity to the supplied design data, concurrent workflow, and accuracy and reliability. Production machining typically involves prismatic parts that can have a simple geometry, but can require complex machining processes with many operations and setups. By automating the programming and optimizing the machining process can deliver significant savings to your business. Conventional CAM systems require the user to create many boundaries in order to generate tool paths on prismatic parts, which is very time consuming and prone to errors. When there is a design change, you need to go through the same process again. With the volume-based milling in NX, the programming process is automated and associative. You select the 3D model faces that need to be machined, and the system calculates the machining volume and generates the toolpaths to remove the material. If the design changes, the toolpaths update automatically. Multiple parts programming enables faster programming of setups with multiple parts. It can save you a lot of time on programming a large number of parts. Multifunction machines let you make parts using milling, turning, drilling in one setup, which can reduce the machining cycle and improve accuracy. These complex machines can be challenging to program, but you can use the advanced tools in NX to simplify the process. You can visualize and control the machining sequence across multiple channels using Synchronization Manager, and the system keeps track of the in-process workpiece, providing seamless transfer of the workpiece between milling and turning. The wide range of 5-axis cutting strategies give you flexibility to address different applications. With the precise tool axis controls, you can safely reach the most challenging part geometry and efficiently machine the part. For example, the ability to accurately specify the tool axis gives you better control over tool load and feed rates, which can extend the tool life. The advanced finishing strategies let you machine high quality parts that not only meet the specification but also have superior surface finish. NX provides smooth tool paths that can follow the natural shape of the part while maintaining the desired tool axis angle that lets you machine better quality parts at higher feed rates. The 5-axis roughing helps you get closer to the semi-finished shape using a minimum number of setups and roughing operations. With traditional roughing operations, you might need several roughing operations on different setups to get to the same semi-finished shape. This also helps you to significantly reduce finishing cycle times. The combined saving of machining time can be significant. To see some of these functionalities in action, we'll look at the next demo showing programming of the knee replacement part. This is a short demonstration of programming a tight tolerance medical implant using 5-axis machining. NX CAM lets you program in the context of the machine setup. By specifying the part, blank and fixture, you can create safe and optimized toolpaths for your application. The part is machined from a casting model which can be easily created in NX. To efficiently remove material, you can position the part on a 5-axis machine and use high-speed roughing strategy for shorter cycle times. A simultaneous 5-axis roughing operation is used to machine the rest of the material. The in-process workpiece capability automatically tracks the uncut material. So the created toolpath targets only the leftover material, which eliminates air cutting and reduces machining cycle times. The precise control of the cutting conditions is critical for successful 5-axis machining. The tool axis settings in NX CAM let you actually define the orientation and position of the tool relative to the machined region. By cutting with the right sections of the tool at an optimum angle, you have better control of the chip load and feed rates, which can extend the tool life and improve overall productivity. Advanced finishing methods let you create smooth and flowing tool paths. You can control the cutting direction and desired scallop height which will directly impact the quality of the machine part. NX CAM lets you create smooth finishing tool paths that follows the natural shape of the part, which can help you achieve high quality surface finish. 5-axis machining can give you some significant advantages. You can streamline the setup process, improve parts accuracy and reduce the overall cycle time. The advanced 5-axis programming capabilities in NX CAM can help you maximize the performance of your machine tools and improve the overall productivity. To reduce errors on the shop floor, you can validate the NC program with the NC programming session. The simulation capabilities range from basic toolpath verification to G-code driven machine tool simulation, which displays the motion of the machine tool driven from the NC output of the post processor. As G-codes are processed, a 3D model of the machine with the part, fixtures and tooling moves in the way the real machine tool will move. Using the validation capabilities in NX, you can minimize tryouts on the shop floor and ensure efficient production on the shop floor. This is a short demonstration of machine code simulation in NX CAM. We have turned on material remover, which then shows the raw material being machined to the final shape. You can collision check against fixtures, machine components, etc., as well as ensure your program doesn't have any access violations. With NX CAM's machine code simulation, you can find any machine related issues before sending to your NC code to the machine. G-code driven simulation is a powerful way to optimize your part manufacturing. Many companies use standalone add-on simulation packages in addition to their CAM system. Multiple data transfers and maintaining multiple sets of data can prevent them from being efficient and flexible. With NX CAM, you can simulate the machine tool inside the same environment where you do the NC programming. This allows you to validate the machining operations as you're doing the NC programming. You can see what the G-code will do, like tool changes, not just the CAM instruction will do. This is an important point because you can validate the complete manufacturing process using the digital twin of the part, machine and the processes within NX. Optimized transition moves for rest milling. This improvement will connect cutting passes with smooth and efficient transition moves for rest milling operations. These non-cutting moves impact the efficiency of rest mill machining. Rest milling toolpaths typically have a lot of short connections containing retract, transfer and engage moves. Although you can choose smooth corners and transfer or rapid, the transitions are still not optimized and smooth enough. Note that it works in cutting feed rate only. With the new transition smoothing, the operation will connect short distances with a smooth and efficient transition. You can get a natural smooth transition without sharp corners and faster machining times. With the new transition smoothing, the operation will connect short distances with a smooth and efficient transition. You can get a natural smooth transition without sharp corners and faster machining times. Edit the rest milling operation, select the non-cutting moves smoothing node, turn on smooth engage, retract step overs, OK and generate. When the operation is generated, you can see the toolpath generation with the new smooth transitions. Report shortest tool calculates the minimum tool length needed to avoid tool holder or shank collisions. Previously, the report shortest tool was only taking the tool holder into consideration. With this enhancement, NX will report minimum tool length, ensuring that both the tool holder and tool shank are collision free. With this new accurate reporting, you can use shorter tools, minimizing chatter and achieving more stable machining. Here we can visually see a collision between the tool holder and the workpiece. Simply run report short tool to get an accurate and easy to understand output. Now we can see that the shortest tool length required is 47.8 millimeters. Now we'll edit the tool to avoid any collisions. Here we can see the shank dimensions, and we go back and we can alter the length of the tool. Now we will regenerate the toolpath, and we can visually see that there are no collisions at the lowest or the highest point tightest to the workpiece. The 3-axis guiding curve operation provides a highly accurate toolpath for excellent finishes. The performance of the 3-axis guiding curve output contact data performance has been significantly improved, which is particularly noticeable when programming parts with complex geometry. This new performance improvement can help you reduce programming times. NX is a complete solution, not just for CAD nor CAM. It's a combination of the two, maintaining full associativity, allowing for changes to be made when required and updating across the board. This also eliminates the requirement for double work of changes being made in the CAM department being communicated across to the CAD team and those changes having to be made again. There are extensive resources with tools, fixtures and cutting data which influence every job. There are extensive tool and machining data libraries, and all this is available inside a fully managed environment. Shop documentation is ever critical, with setup sheets, tool lists and operation sequences easily generated. Integrated machine code simulation and supports machine cycles, subprograms and structure output, ensuring that the information being generated is correct and reliable. NX-CAM's consistent toolpath quality increases productivity with faster programming and full support of robots and complex machine tools. That is it for me today, and I will be answering some questions at the end, but for now I will pass you over to my colleague Heinrich. He's going to take you through the key features of Technology Manager, which is a NX-CAM plugin developed and created by Janus Engineering.
All right, Donna. Thank you for your invitation having us. My part for today's webinar is to show you our tool management system, the Technology Manager, or TMGR for short, by Janus Engineering in Germany. First of all, let me open it up, please. Just as always, making a program work. While it is opening, I can explain you what we are about to see. We will see how we are about to implement or create an all new milling tool, and afterwards, if the time is still right for us, we also will create a new turning tool for us. Well, in the meantime, the Technology Manager has opened up. Let me lose a few words for the interface. On the left side, we have a section that's called assemblies. That means that within its sub classifications, we can see milling assemblies or even going down by showing end mill assemblies only. When I click on the end mill classification, I will see all my existing milling tools within my database. When I click one of those, I see that the preview below here is also getting updated instantly. The preview is a 3D dimensional picture of the tool. I can take a closer look at it. I can zoom in, I can zoom out, I can take a closer look at the tool itself. If I don't like the 3D dimensions, I can switch back to the good old school 2D preview of the tool itself. All right, well, if I want to take a closer look in a particular tool, let's call this tool that I'd like to take a closer look at. I'm just making a double click on it, and then I get way more information about the assemble tool. For instance, what are the components of this assembly? In our case, it's this holder, and it's also this end mill. Okay, how can we search for a particular tool? Let me just delete this search in here. For this, we have a search bar up here. When I click into it, I can start to type in like diameter. The system suspects me that I'm searching for a tool diameter. And now I'm searching for a particular diameter, and the diameter shall be 20 millimeters. By applying with the Enter key, I get all the results according to my search. So now I see all my end mills with a tool diameter of 20 millimeters. Well, this search is a very powerful tool to have, especially because I can grab this search and save it as a so-called favorite search. So now the diameter search is always there for me. I can activate it, I can deactivate it by just making a check mark in the front area in here. If I want to change the value, so instead of 20 millimeters, I'm searching for a 32 millimeter diameter, just change the value of it, and there we go. Now I get all my 32 diameter tools listed. I also can add another search criteria for that. For instance, I don't know, let's call it corner radius. Corner radius is supposed to be bigger than 2 millimeters. Apply with the Enter key, and there we go. Now I see all my end mills with a diameter of 32 millimeters and a corner radius that's bigger than 2 millimeters. So that's how fast we can search for a particular tool. This search, this favorite search, is now connected to the end mill classification. If I switch to the ball mill, for instance, you will see that the corner radius is no longer available. Or better said, it's not longer visible for us because a corner radius is not actually that, sensible within a ball mill at all. When I switch to a chamfer mill, I get no favorite searches so far. I should add one. For instance, I'm searching for a flute length that's less than 7 millimeters. There we go. That's the only result I have for a flute length less than 7 millimeters. I will delete that search, and that's actually it. Good. Well, that's the assembly section that we just have met in here. A little bit down here, we have a section for the base tool themselves. Not the assemblies of a milling tool, but just the base tools. For instance, just the end mills. In this list, I see all my end mills listed. The same goes not just for the base tools, but for the components as well. What do we mean by components? We mean tool holder, for instance, HSK 63s in here. When I click in the list, you see that there are a few of them already existing. But okay, let's create an all new assembly tool for us. We will begin with the base tool. For this, I'm clicking into the base tool section and decide to create a new end mill for us. For this, I'm clicking on the end mill section and will now hit the big red plus icon that's called create new item. The system asks me, okay, what kind of tool do you want to create? Either milling, drilling, turning tool, or do you want to short pass this and switch right into the end mill section? I am selecting the end mill section now. Okay, there we go. Now we see a preview of the new base tool that we are about to create. Just like within an X in the default version, you can start to change the tool's diameter on the left side on this table view. Or what I prefer even more is I can double click on one of those values and change the flute length now. So instead of 50 millimeters, it's going to be like 30 millimeters. Instead of 75 millimeters, it's going to be like 50 millimeters, and so on. The same, of course, goes for the shaft as well. Instead of 25 millimeters, I want it to be like 18 millimeters, and the shank length shall be 5 millimeters. There we go. So now I have created the geometry of the all new base tool. I'm also able to add even more information on that tool. For instance, what is the tool's description now? And the tool's description shall be Kaizen diameter 16. By clicking on next, I'm getting a final preview of the new base tool. By clicking on finish, the tool now is being created. The base tool is being created. Okay, so that's the first part of an assembly tool that we want to create. But for an assembly tool, we also need a tool holder. And for that, I also have something prepared for us. So let's say I want this tool holder to be used in my technology manager. That tool holder is a simple step body that I imported of one of those manufacturers worldwide. It was a step um, file. I imported it into an X. So now it's a typical, let's call it stupid body geometry that we have. But how can I use that body now to create a tool holder that is an X conform? Well, let's return to a TMGR. We are going down to the component section. Now I'm hitting the red plus icon that says once more create new item. The system asks me what kind of item is it that you want to create. Is it a turning tool? Is it an adapter? Or is it a milling drilling component? In our case, it's a milling drilling component. What is the characteristic of the tool holder? It's an HSK 63mm holder. Okay, just like before, we have our new preview in here. For now, the preview is quite empty. How can we start to create a tool holder? I will show you 3 ways for that. The first way is the common way, as you all know it already from an X. We can start to define those sections, for instance, lower diameter 20 millimeters, upper diameter 20 millimeters, and a length of 10 millimeters. There we go. That's the first section. Now I can add a second section, and the tool holder will be built up just like so. I don't know, but if I compare this process with all those steps in here, with all those sections that are possible and necessary to create, it's a little bit a long way to get it done. So therefore, we at Janus Engineering, we decided to create an import for that. Let me show you how we do so. I'm going to the graphics tab on the left side, and now I will hit the import 3D model icon. By clicking on it, the system changes right into Siemens NX and tells me exactly what to do now. So select the tool face. That's supposed to be the face where the tool will be attached in the aftermath. So that's the tool face now. Now the system wants to have the spindle face. So let's select it. That's the spindle face now. By clicking on OK, Technology Manager begins to rotate the tool holder's geometry, and not just by rotating it and importing the step file as well, we are also creating parametric step sections automatically. That means that every single step that was previously necessary will be created automatically. Let me show you what we've got in here now. So when I decide to show the parametric view only, I get the parametrics out of the tool holder. That's the diameter, upper diameter, lower, the length, and so on. Every single thing that I have done by hand previously. I also can take a look at the 3D model of the tool itself. We imported the step file of the tool holder. The last thing that we can select in here is the parametric 3D model. So we can take a look at both of them and if the steps are fitting or not. One more thing, if I go to the More tab, I see now that there are 11 steps created automatically without the need for me to type them in by hand each single time. I also will give it a description. This description will be Kaizen holder, like so. And by clicking on next, we will get a final preview of the tool holder. By clicking on finish, we are almost done. Now the tool holder is added. Okay, now as we have the base tool and the tool holder, it's time to combine them. For this, I can switch to the assembly section and, as always, click on the red plus icon, create new item. The system asks me once more, what kind of assembly do you want to create? Is it a milling drilling or is it a turning assembly? In our case, it's going to be a milling drilling assembly. The new empty preview screen appears. What do I want to add? Actually, I want to add a base tool first. I'm clicking on the base tool icon. Either I can go in each classification to check out for the Kaizen tool, or I could search for a tool diameter, for instance, or I also can search for a particular name that we have given it. There it is. That's the Kaizen diameter 16 holder tool that we just created a few minutes ago. I will click on OK. Now the base tool is added. What else we need for the assembly? We need the tool holder. For this, I'm clicking on the plus icon at the tool holder's place. Once more, I will search for the Kaizen tool holder. There it is. Apply with OK. So there we go. We have the base tool and we have the tool holder. One more thing that we have to check out is the stick out length, of course. For now, the stick in depth is 0 millimeters. Either I can change it to 20 millimeters. Now we see that the tool got stuck in by 20 millimeters. Or I can also start to change the stick out length. And I want it to be stick out by 80 millimeters. The tool number can be added for this tool, 1337. The description can be added. It's going to be the Kaizen assembly, like so. And one more thing, if we take a closer look at the left tab, so again, we see a section that's called cutting data. I will click on it, and what can we do in here? I can add a particular part material. That's going to be the workpiece material, in my case aluminum. I also can add a surface speed for this particular part material and a feed per tooth, like so. Not just one part material can be added in here, several part materials can be added. So instead of the just aluminum, I also will select another steel for this tool. And in this steel, we have to go slower, therefore the values are lower now. Now, as I'm finished, I will click on Next. We are getting the final preview once more. And this time, before I just click on Finish, I want to do another thing, and it's the so-called Create Assembly 3D Model in NX. By activating this icon and click on Finish, I'm switching to NX now, so we can see what is happening in the background. Technology Manager is getting all those data that we just added and creates a 3D assembly within NX itself. So therefore, we will use this very new tool now in any CAM session as a 3D assembly tool. Let me show you the example now. I'm opening up a already existing CAM file in here. And in this CAM file, back then, I don't know when, this operation was created for milling those pockets. But this time I don't want to use the old tool in here. I want to use the new tool that we just have created, the Kaizen assembly. For this I'm selecting it, and how can I send it into NX? With this little black arrow in here. So when I click on it, we will see that the tool appears in NX. And now, as we see, we also have the whole tool's geometry in it. Not just the base tool with its diameter and flute length and so on. We also get the whole holder component as well. And now I can start to use that tool as always in NX. So I've mentioned that I want these two pockets to be manufactured with the new tool. So I'm just grabbing it, drag it down here, making a right click and generate. And the operation is actually done. So I can start a new verification on that to see how the tool behaves down there. Just like so. Okay. One thing that we have to keep in mind is that the feeds and speeds are still the feeds and speed from the previous old tool. How can we now add those new and current feeds and speeds for that very new tool? You remember that I added some feeds and speeds for aluminum and steel, and now it's time to get those feeds and speeds into an X to that operation. On the left side, we have few icons more. The first one is the database. That's the database that we already met. We also have an icon that's called technology. When I click on it, SpeedMill now is checking out every single operation within an X that is selected. In my case, it's the German word for pockets, Taschen. We see it's the same name in here. We also see the base tool or the tool that is being used for this operation, and it is this number in here, exactly. The parts material according to the used workpiece within an X is aluminum. What else we see? We see that the current value in feet per tooth is 0.06 millimeters and a surface speed or a RPM of roughly 4,000 rotations per minute. But the calculated value according to our database is supposed to be at 0.08 millimeters feet per tooth and a little bit over 2000 RPM. How do we get those values now into an X? For this, I just will click on this little icon that says send data to an X. And that's actually it. Technology Manager now has finished the transfer of the feeds and speed into the new tool according to the parts material. So let's switch to an X. Once I click in this area, you will see that the feeds and speed will change. So take a closer look. 3, 2, 1. There we go. Now we see that the current values are correctly according to the tool and the parts material. I also will make another change now. Instead of aluminum, the workpiece that I'm using in here will be made out of the steel that I also have created. So I'm switching the parts material now. And within Technology Manager, I will reload the whole list without having an operation selected. And what we see now is that SpeedMill has checked out, not SpeedMill, pardon me for that, that the Technology Manager has checked out every single operation that is being used within an X. According to the tool, according to the parts material, we see a mismatch now between the current value within an X and the calculated value within TMGR. That means that I would have to change every single operation by hand, but not with Technology Manager. I was just toggle into the compact mode, and when I hit on the send data to an X icon now, every single operation will get its correct value now. So when I update the list in here, we see that every tool, every operation got changed in its feeds and speeds. So yeah, actually that's it. I still have a few minutes more left. I think I will use the time to show you how we are working with turning tools. For this, I also have opened up a turning tool. It's gonna be this here. As you see, it's also just one single body without any other informations. How do we get this body as a tool holder within a TMGR? I'm just going the same way, just like before. Create new item. What kind of item is it though? It's gonna be a turning up component and it's gonna be a turning out tool. Just like before, go to graphics, select the 3D, import model. Now the system asks me to select the holder bodies. There we go. Select the tool mount junction. It's gonna be on that in here. So that's the coordinate system for the spindle to get the holder. Insert reference point. Where is the insert being mounted on in this point? And what is the insert's orientation? That's gonna be the insert's orientation. By clicking on OK, Technology Manager begins to import the part as a step file, and the part gets its information where and how to mount it, either on the machine side or also on the holder sides. And that's it. There it is. Now the tool holder got imported. I can give it a description, Kaizen lathe holder, and click on next. There it is. Clicking on finish. And there is our new tool holder for the lathe machine. Time to combine that. We are now creating a new assembly. So switching to the assemblies, hit on the red plus icon, create a new item. What kind of assembly is it now? It's going to be a turning assembly. And it's going to be a turning assembly for the outside turning. Let's begin with the tool holder this time. So selecting the tool holder that I want to use, and it's going to be a Kaizen lathe something. There it is. So the holder got found. Now as the tool holder is added, I also have to add an insert that needs to be used on that holder. For this, I'm going to the base tool and I'm selecting an insert that fits to my holder. In my case, it's going to be this insert here. All right, by clicking on OK, we see that the tool now is being combined. One more thing that I have to configure in here is the orientation angle of the insert within the tool holder. I will now make a double click on the insert. And now I have the possibility to turn the insert around until the orientation angle fits, like so. Okay, now as the orientation angle is correct, I can add a few tracking points on that. So let's go into our tracking point editor. That's the insert. I want to add a new tracking point for this specific radio, and that's going to be my tracking point now. Click on accept. And that's actually it. That's how we are working with lathe tool. One click on next. We see the last preview of the assembly tool. And we also can mention that the create assembly 3D model in the next is also already activated, because when I click on finish, TMGR begins to assemble that tool within an X as an assembly part. And that's actually it. I can now send that new tool into an X. There it is. I'm just grabbing it and putting it into the right pocket. And we see that the tool is in its correct position. Okay, maybe that's a bad example in here. I just will try to fade out the machine's plate so we have a better view of the turning tool in the correct position. There we go. All right, that's actually it. From my point of view, Dana, I'd say back to you. Thank you for the attention. And yeah, if you might have any questions, do not hesitate to ask them. Have a good one. Bye.
We have a question here It's, can the CAD model be modified in the CAM environment? That's a great question now. Yes, absolutely. You just switch the application from manufacturing to modeling, and depending on where the model came from, if it was a step file, you could use the synchronous modeling tools to easily modify the required features, or if it came in from a NX native file, you could easily just edit the various features, and that's as simple as it gets. Once you go back into your manufacturing environment, you can regenerate the operations and everything will update as easy as that. There's another question: how would one go about programming a turbo impeller to reduce vibration on the thin blades or splitters? Another great question. You could use a merge toolpaths job there, so you could literally group your roughing passes with your finishing passes. So as the operations move down the blade, you're doing your roughing passes on each level, followed by your finishing passes, and then you go down a level, do the roughing, do the finishing, and then go down. And that way you're ensuring that you have the maximum amount of material and preventing or limiting the vibrations on the blade, which will then give you the most optimal finish on the blades. Okay, I see we are slightly over time. Any questions which we didn't get to will be answered by mail, or if you have any further questions, please mail me at donna@kaizenplm.ie or info@kaizenplm.ie. We are also hosting another webinar on utilizing NX CAM and Productivity Plus for on-machine probing, in-process control, decision-making and adaptive programming. And this is taking place on the 24th this month, starting at 11 AM. I will send out more information on this and the registration link. So I hope to see you all there, and I hope you enjoyed today, and thank you all for attending.